Okay, good evening. Can you all hear me? And also, can you see the screen? Okay, then let's begin today's session. So let's see, what did we cover? So we did cover all of these slides. We started discussing the difference between AI, ML, DL, right? Then we moved forward and we discussed. So good evening, everyone. Okay. So if there is someone who is joining the session for the first time today, please do tell me. If not, if you are joining the session for, I mean, the second time or the third time, then I mean, you already know me. I don't need to introduce myself. But if you're new to the class, do tell me. Then I'll go back and maybe revise some of the things that I talked about in the previous two sessions. Okay. So recall what we did in the previous session. We discussed the three different sort of branches of machine learning: unsupervised learning, supervised learning, and reinforcement learning, right? So can anyone remind me what is supervised learning? When do we say that a specific task is falls under the domain of supervised learning? Let's see if you paid attention to the previous session or not. Training with label data. Yes, exactly. So there would be an input, there would be an output, right? And you'd like to learn the mapping or the function between the input and the output. Okay, so let me see if I can write here. So you have an input. I hope you can see the annotation. So there would be an input, okay, and there would be an output, okay, and there is a relationship between the input and the output, okay, some function between the input and the output, right? For example, we say, I mean, we took this example of f of some sentence, okay, some sentence whose sentiment I would like to know, right? Is this sentence a positive sentiment sentence or a negative sentiment sentence? Okay. So, I mean, if given any sentence, okay, the movie was long but interesting, right? This is a sentence, this is a review for which there is a sentiment associated with it, right? There is either positive or negative sentiment associated with the sentence. Okay. Now, I do not know what the sentiment should be, right? There would be some function, some unknown function f, which takes this sentence and spits out whether the sentiment is positive or negative, right? So supervised learning deals with somehow finding this f, okay, somehow modeling this f. Our brains do it, right? We read a sentence and we can immediately say whether whether the sentence is a sentence of positive sentiment or negative sentiment, right? Or if you ask me to differentiate between a cat and a dog, right, my brain has the capability of implementing a function, right, that can differentiate between a cat and a dog, right? So somehow I want my machine also to learn such a function between the input and the output. Okay. So whenever you have a task, the first thing that you need to decide, right, before even asking yourself if machine learning algorithm can be used or not, is to decide whether the problem is a supervised learning problem, an unsupervised learning problem, or reinforcement learning problem. Okay, that's the first step. So if you have an input, you have an output, and somehow you'd like to learn a relationship, a mapping, a function between the input and the output, then it falls in the supervised learning setting. Okay. So, okay, next, what do we do in unsupervised learning? Can anybody remind me? What do we do in unsupervised learning setting? Is there an output in unsupervised learning, or do we care about the output? Finding patterns, on there is saying finding pattern, exactly. But I mean, do we care about the output, or does our data have output? Training with no output, exactly, right? So no output. Okay, yeah, Vishnu is also saying, Vishnu Priya is also saying no output. That's exactly the point. In unsupervised learning, we do not have the output, or we do not care about the output, right? We only want to find patterns within the input. Okay, so there might be output, but for the time being, I do not care about it. Okay, I just care about the input, right? And we took this example of market basket analysis, where, recall, we took this example in yesterday's session, that if you buy bread, you're very likely to buy butter, right? So if a shopping complex, if a mall places butter beside bread, right, it would be beneficial for the shopping center, right? If you pick butter, you're very likely to pick sorry, if you pick bread, then you're very likely to pick butter also, right? So keeping butter near bread, right, in the shopping center makes sense for it, right? But how do you find such associations between different items, right? So bread is not related to a shirt, right? Or sugar is not related to I don't know, sugar, maybe shoe. Okay, so there's no relationship between sugar and shoe, right? Sugar might be related to salt, right? If you pick sugar, you are also likely to pick salt, maybe. Okay, so but how do you find such patterns in the data? And again, mind you that here we are trying to find patterns within the input. Both bread and butter are inputs. These are not input and output pairs. Okay. And we are trying to find such patterns within the input. That's what unsupervised learning deals with. Okay. In most situations. Okay. You might also see problems like clustering in unsupervised learning. So let me briefly talk about clustering, what it does. Okay. So in clustering, what you'd like to do is suppose, recall that we had seen a graph, right, in yesterday's session, and we plotted some points, right? We plotted some points, some male points were here, right, and some female points were here. Okay, so now suppose I do not care about the male and female, so there's no output, right? Recall that the gender of that particular person was the output in yesterday's class, right? Suppose I do not care about the output anymore. Okay, so now I just have some points. Okay, I just have some points, and now the question is, can I form clusters? Okay, some groups within the input. Again, I'm repeating this. I do not care about the output. I do not pay any attention to the output. Okay, I'm only seeing the input. This is how the input looks like. It seems like there are two clusters. This is one cluster. This is another cluster. Okay, how do I find such clusters? Okay, with naked eye, it's possible for us to see such clusters, right? But when you go to real life data sets, it's like, you have only height and weight, right? This is what we saw in yesterday's class, right? Two features of human beings, right? But in real life situations, you'll have many features. Okay, these are also called features. Okay, features in your data set. So in real life, you might have a person's height, his weight, his sex, his salary, his the income tax that he pays. Okay, his, I don't know, birthday, is he married or not, and so on and so forth. You'll have many features about the person, right? Now, if it's in 2D, I can plot it, right? If it's in 3D, again, I can still plot it. It would be a bit difficult, but still I can plot it. What if I go to 4 dimensions, right? If you have height, weight, age, and salary, I can't plot it, right? I can't plot and visualize it. So plotting and visualizing by human eyes, that's not a feasible way of coming up with clusters. Okay, so how do we find clusters in such situations? Okay, so we have algorithms for them also. Such algorithms are again in unsupervised learning. Why? Because here also, again, we do not care about the output. We only care about the input. Okay, so let me pause here. Do you have any questions? I haven't talked about this part yet, dimensionality reduction. I might talk about it later. Okay, so I'm touching upon some of these things, okay, one by one, because if I start talking about everything in one go, it might be a bit confusing for all of you. Okay, so we have seen what supervised learning is, right? We have seen what unsupervised learning is. I just discussed clustering now. So do you have any questions until this part? Or would you like me to repeat any of the parts that we covered in yesterday's session, or any? Okay, so I'm assuming that everything is fine. Then let's move ahead. Okay, so finally, reinforcement learning, we won't talk much about reinforcement learning, okay, because it's quite an advanced course. Okay, in reinforcement learning, our objective is to somehow behave optimally, okay, in a reward punishment setting, right? We took this example of learning to ride a bicycle, right? When you're trying to learn to ride a bicycle, or say you're trying to learn to swim, right? You do not work in a supervised or unsupervised setting. Okay, what you work on is in an environment where you get rewards and punishment. If you fall down, right, if you pedal or if you pull your brakes but you fall down, then you get a punishment, a negative reward, right? But if you do not fall down, if you keep on moving forward, then you get a positive reward. Okay, so somehow you have to learn to behave optimally. Okay, you'd have to learn when to pull the brakes, when not to pull the brakes. Okay, when to pedal, when not to pedal, given this situation. Okay, given this entire scenario where you have positive rewards and negative rewards. Okay, that's a paradigm of reinforcement learning. Okay, so these are the three broad divisions of machine learning: supervised, unsupervised, reinforcement, right? So in supervised, we explicitly saw one algorithm, right? I mean, now you know one machine learning algorithm. Okay, you can go back and tell people that you know one machine learning algorithm. What is the machine learning algorithm that we learned yesterday? Does anybody remember the name of the machine learning algorithm that we learned yesterday? KNN, exactly, right? We learned KNN yesterday, right? K nearest neighbors, right? Today I'll maybe try to show you the code, okay, for KNN. I mean, I won't go into the details of the Python code because I mean I know that a lot of you do not know Python, so I'll just briefly tell you what I'm trying to do. Okay, but I'll just skip the part of how, right? How to do that in Python. Okay, I'll just give a brief idea of what you need to do, okay, to implement the algorithm. Okay, and we'll see the algorithm, we'll see how it performs, okay, on a specific data set and so on and so forth. Okay, so that's a objective for today. I'll try to cover KNN in somewhat more detail. Okay, but before we move to KNN, let me discuss this part a bit more. Okay, uh, so it might be good if I switch to okay, so but I also wanted to discuss. Okay, so maybe I'll just switch to my iPad. Okay, I'll need to write a bit. Then we'll come back to this slide. Okay, we'll then discuss the KNN algorithm, and I'll also discuss the roadmap to become a data scientist. Okay, and the syllabus. Okay, so let me stop sharing and let me share my iPad screen. Meanwhile, if you have any questions, if you want me to repeat any part, please feel free to ask any number of questions. Okay. Okay, so I hope you can see the screen. So let's quickly recall what we saw yesterday, okay? Just briefly. So we saw this division of machine learning into supervised, unsupervised, and reinforcement, right? Okay, so Shanti Singh, can you give me some examples for clustering? Okay, so I mean, I do not plan to actually cover unsupervised learning. Okay, what we're covering is supervised learning. Okay, so KNN is like a supervised learning. I'll discuss this a bit more. So, but okay, I'll maybe try to give some examples of clustering towards the end of the class. Okay, it was not part of what I planned to discuss, but I'll try to give some hints or some references to clustering. Okay, towards the end of the class. So just stick around. Okay, so yeah, this is supervised learning. Okay, and we took this example yesterday of a data set. Okay, a data set where I have somebody's height, somebody's weight, and somebody's gender. Okay, these are the inputs. These two columns are the inputs. Given somebody's height and somebody's weight, the question is, can I predict his or her gender? Right, so this is the output. Right, so the first thing that you should note is that this is the input and this is the output, and you want to learn a mapping between the input and the output. So immediately you should understand that this is a supervised learning task. It's not unsupervised, it's not reinforcement. Okay, now we saw that you'll have a training data where you know the gender, right, where you know the output. Somehow from this you have to learn. Okay, and at query time you would be given an unknown point. Okay, at query time you'd be given an unknown point for which you won't know the gender, and your objective, your task is to predict the gender. Okay, so you need to make this prediction by learning from this training data. Okay, so you have the training data and you have query points. Okay, so far so good. And Now, how do we do this? Okay, so I mean, for the first point, it's easy, right? It's 175, 85, right? So you can go into your data set and you find a point which is exactly equal, okay, to this point, right? 175, 85. It exactly matches, right? So I can output male here, right? But for the second point, 150, 46, you do not have any data point, okay, which exactly matches this, okay? 150, 45 is near to this data point, okay? 150, 46, okay, but it's not exactly equal. So can I put female here? Okay, that's the question. Okay, and here comes, I mean, this is where we discuss the one of the most important aspects of machine learning, generalization. Okay, our objective is not to just memorize some training data. Okay, it's not enough to just memorize this data. Somehow from the training data I have to generalize beyond these data points. Okay, that's a task of machine learning, and that's a task of intelligence also, right? If you think about it, we as human beings, we generalize all the times, right? I mean, when we were, say, when we were giving our high school exams, right? I mean, uh, the question paper would contain questions which are not there in the textbook, right? But somehow by practicing the questions from the textbook, we learn something, and then we can apply that idea, we can generalize it beyond the questions given in the textbook, right? So we, as intelligent human beings, we always generalize beyond what we have seen as part of examples, right? Even when a child learns to differentiate between cats and dogs, the child might see a few breeds of cats and few breeds of dogs. Okay, the child, I mean, would not have seen all the breeds of cats and dogs, right? But somehow from these limited data points, it learns to generalize. Okay, somehow generalize that cats have whiskers, the ears of cats are pointy. Okay, the dogs do not have whiskers. Okay, their ears are flappy, and so on, right? So somehow it learns some general features, okay, about cats and about dogs, and now given a new data point, okay, some breed of dog or cat which the child has not seen, yet the child can differentiate between a cat and a dog. Okay, it can tell you whether it's a cat or a dog, right? So this idea of generalization is very important. Okay, and then we went ahead and we learned this KNN algorithm, where the algorithm is very simple. Okay, it's a very simple algorithm. Okay, by the way, an algorithm is just a stepwise procedure to do anything. Okay, any stepwise procedure to do or complete a task is called an algorithm. Okay, so here, what are the steps? The step is, given any data point. So given any data point, okay, this blue data point is a data point at query time. Okay, the red points are the female points, the green points are the male points. These are the training points, right? So given any data point, first what I do is I find its nearest neighbors. How many nearest neighbors? It depends. Okay, you find maybe 3 nearest neighbors, 4 nearest neighbors, whatever. Okay, in this example we are considering 3 nearest neighbors. Okay, so I ask, this particular point asks its 3 nearest neighbors, 1, 2, 3, right? And goes with the majority, right? Here all 3 of them say female, 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 right? So I'll label this point as a female. Here, if I take this blue point, okay, it also asks its 3 nearest neighbors. All of them say male, 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 so it goes with male. Okay, if I take this particular point, maybe, okay, I mean, this is not to scale, but suppose that the 3 nearest neighbors are this, this, and this, right? So one of them says male, the other 2 say female, right? In that case, again, I go with majority. Okay, and I label this particular point, which is given to me at query time, okay, as female, because the majority said female, right? So this is a very simple algorithm. Okay, but the key point here that I want you to observe is that it generalizes beyond the training set, right? It's not like if you are given a query point which falls exactly on a training point, only then you can make predictions. No, you can make predictions about any point. Okay, if you have a point here, okay, even then you can make predictions. Okay, you'll ask the 3 nearest neighbors. Okay, 1, 2, maybe 3. Okay, the majority says male, so you'll go with male. Okay, so you are generalizing beyond the training data. That's the most important part. How good the generalization is, that's a different question. Okay, there are ways of measuring how good the generalization is. Okay, how good my model is my model powerful enough or not? Okay, so those are, I mean, difficult questions to answer, but they are separate questions. Okay, at least now I'm generalizing beyond the training set. Okay, so let me pause here. If you have any questions until this part, or if you want me to repeat some part, do tell me. Okay. This is what we saw in yesterday's class. So this is where we stopped yesterday. So now we'll move ahead from here. I'll try to show you a code to implement this KNN algorithm. Okay, but before we move there, I'll sort of discuss some of the machine learning algorithms, some of the most popular machine learning algorithms, and also what are sort of the tools, okay, and techniques that you need to pick up to become a data scientist. Okay. Okay. So, but before we do that, let's make this session a bit more chatty. Okay, for some reason you guys chat a lot less. Okay, so if you want to unmute yourselves and ask questions, it's completely fine. Okay, so we also have, I mean, I think we have somewhat less students today, right? So if you, I've given you the permission to unmute yourselves and speak. Okay, so how many of you have already taken a course in machine learning? Some basic course on machine learning. How many of you have taken some basic course on machine learning or have seen machine learning a bit rigorously previously? Is there anybody who has seen machine learning in somewhat detail previously? Sandhya is saying no. Okay. Others do. I mean, do speak up. Okay. It's not an exam or something. Okay. It's just a session. It's so I'm doing masters in AI and DS. Okay. Okay. So that's good, Chandu. So I'm saying not much, sir. So I mean, so most of you are like thinking whether to transition to machine learning, data science or not, right? I guess that's the current situation. So, okay. So I hope this session sort of gives you somewhat more idea. I mean, you would need to go back and do a bit more research, okay, on these things, but I hope this session, I mean, these few sessions would help you in understanding the current literature in machine learning and in deep learning, and to sort of figure out whether it's something that interests you or not. Okay, so I'm trying my best to sort of get you interested in machine learning, because I'm a machine learning enthusiast. Okay, I'm a researcher in machine learning and reinforcement learning, so I'm pretty excited about the field. So I just go on convincing people to come and join machine learning, because one thing is like we have a lot of job opportunities in the market in the field of machine learning and data science, and we have very few qualified people. Okay, to be honest, we have very few qualified people who understand machine learning in detail, in data science in detail, who have the, I mean, requisite amount of expertise to sort of build systems from scratch and also to sort of make decisions. Okay, I mean, you might know people who work in data science, who work in machine learning, but many of them, to be brutally honest, do not understand what each of these algorithms do. Okay, what are sort of the assumptions made by some of these algorithms? Okay, so I mean, there are many algorithms in machine learning. So there's algorithm 1, there's algorithm 2, right? Which algorithm do you pick? Okay, do you pick algorithm 1 for your task, or do you pick algorithm 2 for your task? To differentiate between, or to, I mean, to make a sort of an informed choice, okay, you have to understand algorithm 1 as well as algorithm 2. You have to understand what are the assumptions behind algorithm 1. Okay, and what are the assumptions behind algorithm 2? Are those assumptions met in your case for your data set, for your task, right? If they are met, then it's a good idea to choose algorithm 1. If they are not met, then you should not choose algorithm 1. You should go and choose algorithm 2. Okay, and so on and so forth. So I mean, you would be able to make such decisions, such informed choices only when you understand these algorithms in detail. Okay, and that's sort of the objective of Innomatics. Okay, to sort of make people understand and appreciate data science and machine learning in much more detail. Okay, than what people currently have. Okay, so let me so we'll come back and. Okay, but before we move ahead, okay, let me quickly do one more classification, okay, and then we'll move to a discussion on the roadmap, okay, and what are sort of the skills required, and then we'll see a brief code, okay, on KNN, okay, and then we'll stop today's session, okay. But before we move ahead, let me now classify supervised learning. right? So, I mean, let's recall that we had classified ML, okay, into three parts, right? So supervised, unsupervised, reinforcement learning, right? So, okay. So we had already classified ML into supervised, unsupervised, and reinforcement learning. Okay. So within supervised, which is sort of the most widely used model in industry these days, okay, I'm very much an enthusiast of RL because I work extensively on RL, but for some reason RL is not yet widely used by the industry. Okay, some people are starting to pick RL. Okay, so a lot of these recommendation engines these days, I hope you know what a recommendation engine is. I think we talked about it. So how does Netflix recommend movies or shows to you? So in those situations, reinforcement learning is being used these days. Okay, even for game playing, automatic game playing, even for self-driving cars these days, or for robot manipulation these days, RL is being used, but it's not used as much as I would like it to be. Okay, the most widely used setting is this supervised learning setting. Okay, and that's the focus of our discussion. Okay, at least for today and tomorrow. So in supervised learning, you have another two classification. Okay, the first one is called classification. The two divisions are, the first is called classification, the second is called regression. Okay. So in classification, the output is something called a categorical variable. Does anybody know what a categorical variable is? Does anybody know what I mean by a categorical variable? Has anybody heard this term? Okay, so let me tell you. Qualitative data, yeah, not necessarily qualitative, it could also be quantitative, but the point is there are finite classes. Okay, there are finite number of classes. For example, if I say positive sentiment, negative sentiment, right? There are two classes, positive and negative. Okay, if I say I want to differentiate between cats and dogs, again two classes, cat and dog, right? Okay, so categorical variable means finite number of classes. Okay, that's what categorical variable is. Okay, so when you want to classify between one of many classes, okay, then it's a classification task. Okay, in regression tasks, your output is not classes. Okay, it's a real value. Okay, it's a real value. I hope everybody understands what a real number is, right? Any real number. Okay, 2.372. Okay, that's not one of the classes. Okay, so say suppose you want to predict tomorrow's temperature. Okay, you want to predict tomorrow's temperature, right? In this situation, you won't be sort of predicting between 2, 3, or 10 classes. Okay, it could be any real number. Okay, tomorrow's temperature could be 28.5. It could also be 31.7. Okay, it could also be 32.565. It could be any real number, right? It's a continuous number. It's not one of many values. Is this difference making sense to everybody? What is categorical variable and what is a real variable? Is the distinction clear? When I call this a task as classification and when I call it a regression, if it's not clear, please do tell me. Okay, it's because it's the second most important distinction, okay, that you need to make before solving any machine learning task. Okay, the first distinction is whether it's supervised, unsupervised, or RL. Okay, that's the first thing that you need to find. The second thing that you need to find once you know that it's a supervised learning task is to see whether it's a classification task or a regression task. Okay, because based on these two different kinds of tasks, the algorithm that you choose might differ. Okay, so in classification, you would like to predict one of many classes, cat versus dog versus horse. Okay, in regression, you'd be outputting a value, a real number. Okay, maybe predicting somebody's height. Okay, predicting somebody's gender is not regression. Why? Gender, I mean, you only have two genders, okay, male and female. Okay, so we are looking at which task. So here, can you tell me what is the task that we are looking at? Is it a classification task or a regression task? Classification or regression? Chandu is saying classification. What about others? Is this task a classification task or a regression task? You need to only worry about the output, right? Only the output. Is the output a real value, okay, or a categorical value? Right? You only need to worry about the output. The output is categorical, male and female. It's not a continuous number. Okay, there are only two possibilities, male versus female. Right? So it's a classification task. It's a binary classification task. Why binary? Because there are two classes, male and female. Okay. So we are specifically looking at classification. Okay. So even in ML, we have come down this path. Okay. And in classification, we are looking at a specific machine learning algorithm called K nearest neighbors. Okay. KNN. But it's not necessary that you use KNN. Okay. You could use some other algorithms also. Okay. So let me just name some of the algorithms so that you can go back. I mean, these are for for the purposes of reference, so that if you go ahead and you want to read somewhat more before deciding whether you want to shift to data science or not, you could look at some of these algorithms. Okay, for classification, apart from KNN, okay, so maybe let me start by writing KNN. So KNN is something that you saw here. Okay, you can also use something called logistic regression. Okay, the name is sort of counterintuitive because it's not a regression task. Okay, the logistic actually does not make it regression. Okay, so I mean, even though it's a classification task and not a regression task, even then you have an algorithm called logistic regression. Okay, or maybe you can also use something called SVM. Does anybody know the full form of SVM? Support vector machine. Yes, exactly. Support vector machine. Okay, I mean, you do not need to worry about these algorithms. Okay, I mean, I won't be teaching these algorithms here. Okay, but I mean, this is only for reference. If you want to go back and read more, okay, you can look at some of these algorithms. Okay, or maybe decision trees. Okay, anything else? Random forest classifier. I'll go to random forest later on. Okay, for a specific reason. I'll write maybe naive Bayes. Okay, in regression, does anybody know any regression algorithm? Any algorithm for regression? Well, for starters, the simplest one is called linear regression. Maybe we'll try to discuss linear regression in tomorrow's session. Okay, because I've already shown you one classification. Yeah, okay, so some people are saying linear regression. Yeah, so because we've already seen one classification algorithm, it might be instructive to learn one regression algorithm also, right? So maybe tomorrow we'll look at linear regression. Okay, or I mean, if you have linear regression, you can also have something called polynomial regression, which is like a generalization of the first type. Okay, you can also use something called KNN regression. Okay, so a regression version of this KNN. Okay, so KNN regression, I mean, many of these algorithms have regression versions. Okay, so support vector regression. Okay, so SVR, support vector regression. Okay, that's the regression version of SVM. Okay, or decision tree regressor, decision tree regressor, which is like the regression version of this decision trees. Okay, and so on and so forth. Okay, and finally, what you can also do is, that's where I'm going to put random forest. Okay, so there are some algorithms which are called Ensembl methods. Okay, so ensemble, I mean, the English word ensemble means a group of some things. Okay, so ensemble techniques are a combination of some things. Okay, so ensemble techniques combine multiple models. Okay, that's what it does. Okay, maybe it combines logistic regression with KNN. Okay, so you have many ensemble methods, and these methods were very, I mean, not where they are still very powerful. Okay, and in many situations, people do use ensemble techniques. Okay, since the advent of deep learning models, okay, people in many situations do prefer deep learning algorithms, but still ensemble techniques are very powerful models. Okay, so random forest. Let me start by writing that. Does anybody know any other ensemble method? And sorry, random forest. Anything else? So yeah, so random forest. I've already written random forest. Anything else? So have you heard of boosting? So boosting is again an ensemble method. Bagging, yeah. Chandu is saying bagging, yeah, bagging, boosting. Okay. Voting ensembles. Okay, stacking, blah blah blah. Okay, there are a lot of ensemble techniques. Okay, so these are also very powerful models. Okay, so yeah, so that's about machine learning algorithms. Okay, then you also have deep learning algorithms. Okay, maybe I'll talk about deep learning algorithms in the last session. Okay, so Friday session, so tomorrow I'll try to discuss linear regression so that you have an idea of what is regression, how to solve it. Okay, and maybe on Friday session I'll sit with a deep learning model. Maybe I'll try to do character recognition. Okay, so digit recognition. Given a handwritten digit, can we recognize the digit? Okay, so we'll take images or photos of handwritten digits and try to implement a neural network, specifically something called a CNN. Okay, I'll teach you what CNN is, and we'll try to implement an algorithm which sort of predicts what the digit is. Okay, given its image. Okay, so we'll try to do that on Friday session. So I'll talk about deep learning models in detail on Friday's session. Okay. Okay. So now let me move back to the slides. If you have, by the way, if you have any questions, if you want me to clarify anything, do tell me. Okay, so okay, so yeah, so we took sort of a detour. So let me get my laser. Okay, and also my writing device. Good to go. So, okay, so in supervised learning, right, we saw classification and regression, right? So now we know the difference between what classification is and what regression is. Okay, that's sort of the second thing you should worry about. Okay, after differentiating between whether it's an unsupervised learning task or a supervised learning task, the next question you should ask yourself is this like a classification task or a regression task? Okay, there are many examples here. Okay, identify fraud detection. Okay, so I mean, some of these credit card companies would like to detect whether this particular person is is going to do fraud or not. Okay, before giving or handing over a credit card to the person, they would like to sort of analyze whether you're susceptible to do some fraud or not. Okay, so that's like fraud detection. Okay, here also you are sort of differentiating between two classes. The first class is fraud, the second class is not a fraud. Okay, so there are again two possibilities. Okay, image classification, you want to differentiate between cats, dogs, horses, cows, and so on. Okay, so again, you have finite number of different classes. Okay, customer retention. Yeah, so I mean, are you going to retain this customer or not? Okay, that's also a very important. I mean, a use case for these companies. Okay, say for example, if you're a customer of Airtel or Vodafone or Jio, okay, the company would like to know if you are going to I mean, if the company can retain you or not. Okay, as a subscriber, right? So it would analyze your calling patterns, your data usage patterns. Okay, the amount that you recharge every month. Okay, and so on and so forth, your age, your salary, if it somehow gets hold of your salary, or the income tax that you pay, blah blah blah. It will try to somehow try to predict whether you are a customer which can be retained, who can be retained or not. Okay, so again, there are two choices. Okay, can you be retained or not? Okay, diagnostics in medical imaging, you'd like to diagnose, okay, whether a particular person has cancer or not, okay, based on his the MRI images of his brains and so on and so forth. Okay, so again, you see cancer, no cancer. Again, it's a classification task. Only two choices. Okay, in regression, you might you have weather forecasting, market forecasting. Okay, so again, these, I mean, the point is that in all of these cases, the output is a real value. Okay, it's not one of possible classes. Okay, it's a real value, and you would need to use different kinds of algorithms to solve these different problems. Okay, so now next, let's move forward. So we discussed this slide in detail. We discussed, computer vision and NLP in the first session as well as in the second session, right? And we listed down a lot of applications of NLP as well as computer vision. Okay. Now, job opportunities. I mean, these days there's a huge boom in the demand for data analysts, okay, data scientists, machine learning engineers, AI engineers, okay, and I mean the market has a lot of open places, but very few people to fill those places. Okay, that's why I mean these many of these institutes, okay, they are coming up with specialized courses, master courses, or even these days bachelor courses on machine learning and AI. Okay, specifically like MTech or MS in AI. Okay, or specialization in data science, okay, something like that. Okay, because the market demands such jobs a lot. Okay, so so role of data analysis. Okay, so in many of these machine learning tasks, a huge role is played by statistics. Okay, and many of other areas in mathematics like linear algebra, probability, optimization. So understanding such things, okay, becomes essential, okay, to be a good data scientist. Okay, so I mean I won't go into the details of what descriptive analysis, predictive analysis and prescriptive analysis is. You can go back and I mean I think the company would share these slides with you, so you can go back and read about these things. But these are things that you need to sort of pick up while I mean in the road to become a data scientist. Okay, so next, some of the market trends. Okay, so I mean by 2025, it's sort of predicted that around 11.5 million jobs would be created, okay, in the field of data science and machine learning, okay, in the whole world, okay, by the year 2026. So you see that there's a huge number of opportunities in this field. Okay, so I mean who can learn data science? I mean it's sort of a misconception that you need to know a lot of coding to be a data scientist. That's not the case. Okay, even if you have not taken coding lessons, even if you're from non-IT or non-computer science background, it's fine. I mean we have had, I think we have already trained about more than 150, I think 155 or some batches. Okay, and I think we currently have around 11 or 12 running batches. Okay, and we have a lot of people who are from non-IT background, a lot of people, okay, from varying backgrounds, from varying age groups. Okay, we have people who are still doing their bachelors, okay, maybe they're in their early 20s. We also have people from their early 40s, okay, who would like to change their uh, I mean career path and move to data science. Okay, and they did not go through any computer science or coding background. Okay, so we have had such people, and they have gone through this entire course and have been placed in such data science jobs. Okay, so it's I mean we have seen that it's completely fine for non IT people also to transition to data science. Okay, so if you're sort of worried whether I'd be able to grasp the concepts or not, you would be able to. Okay, trust me, you would be able to. So some of the topics that you need to master, okay, to be a data scientist, a good data scientist or a machine learning engineer. So first, obviously, you have to start with a language, okay, because at the end of the day, you have to implement. Okay, it's not just about learning stuff. You have to learn stuff and then implement those stuff to be able to construct deployable models. Okay, so towards that, you need to learn a language. Okay, a computer language in which you need that can be used to implement the algorithms. Okay, and I mean, the most ubiquitously used language out there these days for data science, machine learning, AI is Python. Okay. I mean, some people do use R for data analysis. Okay. For data analysis, it's still possible to use R or maybe even MATLAB. I also sometimes use MATLAB, okay, for some numerical computations and so on and so forth. But for general purpose machine learning, Python has sort of dominated the entire market. Okay. So I'd suggest, it's my suggestion that, I mean, if you plan to transition into data science or machine learning and you have to choose between R and Python, okay, or some other language in Python, pick Python, okay, because you have a lot of open source libraries in Python which are not available in other languages, okay, because a lot of people have contributed to Python. The entire library of Python has become so rich that you need to write a lot less code, okay. You can use somebody else's code, okay, because so many people have contributed to Python, okay. So yeah, so obviously first you have to learn Python, okay. Then comes statistics and probability, okay. This is the maths part which you need to sort of have a good grasp on to understand many of these machine learning algorithms, okay, because they are heavily derived from statistical viewpoints, okay. Then SQL. So does anybody know the full form of SQL? Or I mean, what do we use SQL for? Just give me a minute. For some reason, my chat is not uh, showing up on my tab. Okay, now it's showing up. Yeah. So Karthik is saying structured query language. Yeah. So structured query language. That's a full form of SQL. Sometimes I think previously it was also called SQL. Okay. Yeah, for database management. Okay. The point is, when you have a huge data set, okay, it's not possible. I mean, I hope everybody knows the difference between hard disk and a RAM, right? So RAM sort of is a temporary memory. Hard disk is a permanent memory, right? So, I mean, when you're doing some computation, you need to load stuff or data into your RAM, right? But obviously, if your data set is very large, right, you can't load everything in your RAM, right? So somehow you'll store it in your permanent memory or hard disk, okay, storage, and then you have to sort of communicate with the database, okay, to load stuff, okay, and that's where SQL comes, because in many of these data science problems you need to communicate with databases, huge databases, okay, which would be stored in terms of tables. You'll have to pick rows out of tables, pick columns out of tables based on certain conditions, okay, and so on and so forth. So for that purpose you need to learn SQL, okay. And Tableau. So Tableau is like a visualization tool which lets you visualize or summarize the data in a very clean manner, okay. So for that purpose, you can learn Tableau also. I mean, Tableau and SQL are not difficult. Okay, in my opinion, they are very simple. I mean, SQL might be. I mean, SQL is again a query language, so it's a language at the end of the day. So you might have to remember some stuff. Tableau is pretty easy. Okay, Tableau is pretty easy. So it's not the difficult part. So next comes some basic mathematics in terms of linear algebra. Okay, matrices, and I might also add some amount of probability and optimization. Okay, so I see two things missing from here. So statistics and probability have been covered here. So, but I should write optimization also here. Okay, this is also a branch of mathematics, optimization, where what you want to do is somehow minimize or maximize a function. Okay, you might have heard of such things. Okay, minimize a function, right? We have seen, I think we've seen such things in high school. Minimize f of x. Okay, say f of x is x minus 2 whole squared. Does anybody know what is the minimum? What is the minima of this? If I ask you to minimize this function, can you minimize this function? What is the minimum value? Does anybody know how to solve it? I think we have seen these things in high school, right? If you have taken high school mathematics, you know minima and maxima, right? How do I find a minima of a function? I take the derivative and equate it to 0, right? Okay, I take the derivative and equate it to 0. Okay, so Shanti saying 2x. Okay, so I mean you can take the derivative. Okay, so it's 2 times x minus 2. Okay, is 0, and then you get x is equals to 2. Okay, I think, I mean, you might have forgotten it, but we did such stuff in high school. Okay, how to find a minimum of a function. Okay, so that entire theory, okay, is called optimization. Okay, it's a fancy name, but it's a simple thing. Okay, the objective is at least simple. Okay, so you need to learn such stuff also. okay, to be able to appreciate many of these machine learning algorithms. Then obviously all the machine learning algorithms, okay, and then deep learning, because these days many of these complicated tasks are usually solved using deep learning, okay, not traditional machine learning algorithms, but deep learning algorithms, okay. And then some of these applications of deep learning algorithms in computer vision, where you work with images or videos, okay, or NLP, where you work with natural languages, okay. So these are some of the things that you need to learn to become a data scientist, okay. So maybe let me now try to uh, so just give me a moment. uh, let me try to map these things to the syllabus. Oh, okay, so I'm not sharing my whole screen, so let me. Vikram has a question. Should we learn in depth these algorithms, or just knowing about is enough? Like in linear regression, calculating gradient descent and cost function, or just importing linear regression? So, see, our objective, at least I can tell you that our objective at Innomatics is not just about teaching people about how to import the class, okay, of linear regression and use it. We would like you to learn how and what happens inside, okay, because the important point which a lot of people miss in the data science industry is that if something goes wrong, okay, you would not be able to do anything, okay, if you do not understand the algorithm, okay. For your data set, for your specific task, if something goes wrong, you would not be able to correct it if you do not understand the algorithm. That's the first thing, okay. Second thing is that many of these machine learning algorithms, okay, I mean, it's not just about blindly choosing an algorithm and just going with it. You have to do a lot of analysis of the data, okay. Recall I had told you that you had a step called exploratory data analysis. Let me just first share my screen, okay, because it seems a bit odd speaking to a blank screen. So yeah, so in many of these situations, you you have to do a lot of analysis, okay. Recall the step called EDA, exploratory data analysis, okay. There you have to analyze the data and then choose which particular algorithm suits your purpose. You'd be able to do that only when you know the algorithm, right? If you do not know the differences between algorithms, if you do not know what's the difference between SVM and naive Bayes, right, how do you choose between SVM and naive Bayes, right? Moreover, on top of it, these algorithms have something called hyperparameters, okay, and you have to do something called hyperparameter tuning. Again, you can do these things only when you know the algorithms. Just knowing the function and just knowing how to import it is not enough, okay. I mean, also, I mean, what do you mean by enough? Okay, it's enough to do a school project, right, or a college project, okay. But if you want to be a data scientist, okay, a thorough complete data scientist who can solve problems end to end, okay, then you should, okay, you should learn these algorithms in detail, okay. Okay, so yeah, so this is the course. So I mean, this is innomatics.in, okay, so you can go to innomatics.in. This is courses, okay, data science, IBM data science. Click on this, okay, and just scroll down and you'll see this entire detailed syllabus, okay, that we cover for this entire course on data science. This is an IBM certified data science course where, I mean, in the first model, I mean, I think the first model is for about a month, okay, more than a month, okay. I usually take more than a month to teach Python. So where we start with Python, okay, we do not assume that you know any language, okay. It's not like you know C, C++, and then we teach Python on top of it. No, we expect you to know nothing, no computer language, and we start from the basics, okay. So we teach Python for about a month. We teach you data analysis using Python, okay. So stuff like NumPy, pandas, these are sort of things that you need to implement machine learning algorithms. Then how to visualize the data, okay, how to plot data, okay. So we'll see some examples today, okay, when we see the code, how to visualize data, okay. Do a lot of case studies in these things. We teach you about regular expressions, web scraping, okay. Web scraping is also a very important part of machine learning. In many situations, you might not have access to data, okay. In those situations, you might need to collect data, okay. Web scraping is a way to collect data from internet, okay. Obviously, you can't collect everybody's data, right? There are copyright I mean, copyright is something that you have to take care of. But I mean, if some data is publicly available, how do you scrape out or search such data and sort of collect the data. Okay, so we teach such end-to-end models in web scraping. So Vikram is saying, what about those already learned Python? No, no, no. So I mean, even if you know Python, okay, you'll sort of see that we do cover Python from more sort of a data science perspective. Okay, so even if you know Python, every day when we teach you something, say for example, you know about lists, okay, or classes, okay, whenever we teach classes, okay, then we'll give some examples from data science. Okay, that's something which you would not know if you have not taken a course on data science or in machine learning. Okay, so it's not like you have to wait if you already know Python, you can join from Python. Okay, and another thing is that we keep on providing assignments. Okay, we keep on providing assignments for each of these modules. Okay, extensive assignments. Okay, which sort of, if you already know Python, okay, you'll sort of have a head start. Okay, but I mean, solving these assignments and going through all the detailed problems that we discuss in the class would make you much more proficient in Python from the data science perspective. Okay, so I mean, I would encourage you to start with the Python module itself, even if you know Python. Okay, because there are a lot of things that we teach in Python which are not covered in a basic Python course. Because I mean, basic Python would not deal with data science and machine learning algorithms, right? They would not deal with such things, right? So I mean, you might not have seen data frames, okay, or you might not have come across Seaborn on Matplotlib, okay, or such other modules in Python. Okay, so these are things that we teach, and I mean, I would encourage you to learn these stuff also before jumping to machine learning. Okay, then we teach statistics. Okay, so statistics, this would be a mathematical module. Okay, where we try to bring again everybody to the same platform where everybody knows the same amount of probability, so the same amount of mathematical background which is required to understand the machine learning algorithms. Okay, then SQL. Okay, so another module on SQL. Okay, then machine learning for supervised learning. So again, I mean, linear regression, multiple linear regression. Okay, evaluation matrix, polynomial. I mean, these are some of the algorithms that we talked about. Okay, I mean, I just talked about a few. Okay, we have a lot more algorithms here: logistic regression, naive bayes. Okay, decision trees, then ensemble methods. Okay, k nearest neighbors, support vector machines. Okay, this is just supervised learning. Then you have unsupervised learning, where we discussed PCA. I did not touch upon this in today's session. Maybe I'll touch upon this towards the end of tomorrow's session. Okay, so this is again a very interesting algorithm. Then clustering. Okay, so clustering, then association rule mining, market basket analysis. Okay, recommendation systems, we cover all of these things. Then we start with deep learning. I haven't talked about deep learning in detail yet, so I'll do that on Friday, and then we can come back and see these three modules. Okay, so we start with deep learning, then we move to computer vision and specifically talk about this CNN model. Okay, so I'll discuss this CNN model on Friday's session. Okay, then NLP, natural language processing, where we discuss RNNs, if you've heard of such architectures. Okay, then many applications of these NLP systems. Okay, then Tableau. Okay, so Tableau, I think Tableau has been moved after SQL, so I think we teach Tableau after SQL, okay, as the fifth module, and then we move to machine learning. Okay, so this is the detailed syllabus for the IBM certified data science course. And I mean, if you see carefully, this sort of matches the roadmap, okay, that you need to become a data scientist. Okay, I think it's more than 6 months. Okay, it's a more than 6 months long course, and after each module we sort of have projects, okay, that you need to complete. You need to give presentations. Okay, and I mean, you'll get a sort of a 1 week off where you work extensively on the projects, you submit them. Okay, I mean, detailed projects after each of the modules. Okay, within each of the modules you will have to submit a lot of programming assignments. Okay, not just programming assignments, but I mean some theoretical assignments also. Okay, so that's the structure of this entire course. If you have any questions on the course material, you can ask me. If not, then we can move ahead with the KNN algorithm. Okay, so they're saying this, no, this is not free. Okay, this is an IBM certified data science course, so obviously this won't be free of cost. Okay, so for details regarding pricing and all, you can contact the team. Okay, so just contact the team. They would, or I think, I mean, if you've registered for the course, I mean, the team would reach out to you, okay, about this course, so you can discuss with the team about the pricing and all. Okay, okay, any other questions? Okay. So then let's move to KNN. Okay. We'll discuss KNN and we'll stop here for today. Okay. Again, disclaimer, I'd be discussing Python code. So if you do not know Python, it's fine. Okay. I won't discuss the what part. Okay. Sorry, I won't discuss the how part. I'll discuss the what part. Okay. I'll just discuss what are we doing. Okay. Not how are we doing this. Okay. So I'll start with a data set. Let me show you the data set. Okay. This is the data set. I'm just showing you the first 5 data points of the data set. Okay. These are the first 5 points of the data set. Okay. This is a data set which has 150 points, of which I'm only showing you the first 5 data points. So let me again bring up my pen. Yeah. So it has 1, 2, forget this. Okay. This is not a column. Okay. This is not a column. This is just some indexing. Okay. Number. This is like a serial number. Okay. It's not a column. This is one column. This is second column, third column, fourth column, fifth column. There are 5 columns, right? Recall we have already seen one data set where we had somebody's height, somebody's weight, and somebody's gender. Okay, that data set had 3 columns. This data set has 5 columns. So 1, 2, 3, 4, 5, right? And what is this data set? Okay, it's a data set of flowers. Okay, where you have the sepal length of the flower. I hope everybody knows what a sepal and petal is. So, I mean, let me try to draw a flower. This is my pathetic attempt at drawing a flower. So, yeah, I hope this looks like a flower to you. Okay, so this part, okay, this is called a petal. Okay, this is called a petal of a flower. Okay, and this is called the sepal of a flower. Okay, the support on which the flower sticks. Okay, that's called the sepal of the flower. Okay, so what is the length of this petal? Okay, that's petal length centimeter. Okay, what centimeter? Because it's in centimeter. Okay, then petal width centimeter. Okay, what is the width of the petal? Okay, then sepal length, what is the length of the sepal? Okay, and sepal width. Okay, what is the width of the sepal? Okay, so you have 4 information. Okay, 4 things that you know about the flower. Okay, and you also have its species. Okay, so this is the scientific name of the flower. Okay, the first name is Iris setosa. Okay, so there are 3 kinds of flowers in this data set. Iris setosa. Don't care about the names. Okay, these are just, I mean, technical names. The point is that there are 3 classes. Okay, previously we had seen a data set where we had 2 classes, male and female. Here we have 3 classes: Iris setosa, Iris versicolor, okay, and Iris virginica. Okay, these are the 3 classes. We will call them 1, 2, 3. Okay, we won't go into calling them setosa, versicolor, virginica. We'll just call them 1, 2, 3. Okay, we don't care about the actual names. Okay, and this data set is called the Iris data set. Okay, it's a very famous data set. Yeah, Chandu is saying Iris data set, exactly. This is a very famous data set. You can go and Google search Iris data set. It's sort of the first data set that you learn about when you start learning machine learning. Okay, so you have 3 classes, and your objective is to somehow look at the sepal length, sepal width, petal length, and petal width of a flower, and try to predict what is the species of that particular flower. Is the task clear? That you would have, I mean, you would look at the sepal length, sepal width, petal length, petal width of a flower and predict what is the species. Okay. Now, can you tell me, first thing, is this, first classification, is this supervised or unsupervised? Okay, Chandu is moving ahead, but first let me ask you, is it like supervised or unsupervised? Chandu is saying supervised. What about others? What do others think? Supervised. Sandar is also saying supervised. Others? Shant is also saying supervised. Okay. So yeah, so this is a supervised task. Why? You have input, you have output. These 4 columns are your inputs. Okay. Swamil is asking, K-means supervised. No. K-means is not a supervised learning algorithm. By the way, we are not looking at K-mean. We are looking at KNN. Okay. K-means is a different algorithm. Okay. It's a unsupervised learning algorithm. Okay. Here we are looking at KNN, K nearest neighbor. This is a supervised learning algorithm. Okay. So is this clear, Saumil? Or did I misread your question? Inputs and outputs. Okay, okay, yeah. So KNN is a supervised learning algorithm. That's correct. Okay, but K-means is a different algorithm. Okay, don't confuse KNN with K-means. So these are the inputs and this is the output. Okay, so you have input to output mapping. So it's a supervised learning task. The next question that you should ask yourselves is this a classification task or a regression task? Classification. Shant is saying classification. What about others? Satleja, Sai Teja is also saying a classification. Others? Classification or regression? You need to ask yourselves, is the output categorical or real? Is the output a real number? Okay, is the output a real number? If it's a real number, then it's a regression task. If it's not a real number, if it is one of many classes, then it's classification, right? So it's a classification task. Why? It's one of three classes: Setosa, versicolor, virginica, right? 1, 2, 3. Okay. So it's a classification task. Okay. And I have 50 points from Setosa, I have 50 points from versicolor, and I have 50 points from virginica. Okay. Just look at the parts that I'm highlighting. Okay, do not look at the Python code and other stuff. Okay, it won't make much sense to you. Okay, so Shanti is saying not a real number. Exactly, this is not a real number. Okay, these are three possible classes. Okay, so ignore these parts. Okay, so how do we learn a model? That's the next question. Okay, so let me just briefly tell you this entire process. What we do is you have a data set. Okay, you have a data set. Okay, the first thing you do is divide this data set into two parts. The first part you use for training. Okay, to what is training? Building the model. Okay, for training or building the model, right? Okay, and you leave some part of the data for testing, for checking how good your model is, okay, or evaluating your model, the model that you learned in the first phase. Okay, I hope this makes sense to all. Say, I mean, let's take the example of preparing for a math exam, right? So you have examples. I mean, you take a chapter maybe on trigonometry, okay? Then you have examples, okay? You have the solutions of those examples, right? So somehow you try to learn what's happening in that question. You try to understand the concept by going through the examples, learning all about these examples, learning all the theorems, how to apply them on the examples, right? But at the end of the chapter, you have exercises, right? You try yourself on the exercises to check how good you are, right? So while going through the examples, for which you have the question, you have the answer, you have the input, you have the output. Okay, to check, to build the model, right? To prepare yourself for that particular topic. Then at the end of the chapter, you have some unknown problems, okay, where you would evaluate yourself. Okay, so that's how you should look at this entire situation. You have an entire data set which you divide into two parts. Training part, this part of the data set is used for building your model, to learn how to differentiate between the three different species. Then at the test time, you go back and check if your model is good enough, right? Your model would make a prediction, right? If the prediction is correct, well and good. If the prediction is not correct, bad, right? Right? So, I mean, if there are 10 points, okay, out of which you make 7 correct predictions. So 7 correct predictions, 3 incorrect predictions, right? Then your accuracy is 70%, okay, or 0.7, right? Your accuracy is 0.7 or 70%. Out of 10 points, you are correct on your prediction. Your prediction matches the correct value, right? The flower is actually Setosa and your model also says Setosa, right? Then it's a correct prediction. But if the actual flower is like versicolor, but you say virginica, that's like a misprediction, right? So suppose your model, the model that you built using the training data, makes 7 correct predictions, 3 mispredictions. Then the accuracy is what? 7 out of 10, right? Which is 0.7, right? Or 70%, right? So you'd like your accuracy to be high. 70% accuracy is not good enough. Okay. Maybe you'd like something above 85. Okay. Or maybe above 90. Okay. So the first thing that you do is to split your data. Okay. Sorry. Split your data into train and test set. That's the first step. That is what we are doing here. You divide your data into train and test sets. Okay. Then you go ahead and build your model. Okay. So then you go ahead. I won't show you the details. Okay. I'm just telling you what we are doing in each of these blocks. I'm not showing you the details of the Python code. Okay. And don't even try to understand the details. Okay. It's not possible for you to understand if you don't know Python yet. Okay. So again, here I'm trying to build the model. This is where I learn the model. Okay. Where I train and build the KNN model. Okay. So this is the model which I'm importing. K neighbors classifier. Okay. And I build a model based on my training data. Okay. And then I go back and evaluate on the test data, right? Recall 2 steps. First, you have the data, you divide it. This is the train data. You build your model here, right? That's what I'm doing here. Okay. Then you have the test data where you need to evaluate how good my model is. Okay. That's what I'm doing in the next 2 steps. Okay. So this is where I'm measuring how good my model is. Okay. My model gives me 0.92. So this is like 92% accuracy. It's a good enough model. Okay. 92% accuracy. Okay. Out of 100 points, 92 are correctly classified by this model that I built. Okay. So this is like the general procedure that you follow. I mean, this is a very simplistic example. Okay. I mean, you don't have many steps here, but this is like the broad skeleton of, implementing any machine learning algorithm. Okay. You'll have some data set. You also do some analysis. Okay. I mean, that's not something which I covered. Okay. That's there in this particular notebook. Maybe I'll share the notebook. Okay. But let me show you that what you do actually is, this is now the way to do it like a boss. Okay. So, I mean, you do a lot of data analysis. Okay. You try to understand the data. Okay. You do a lot of data analysis and then you go ahead and do data preparation and then you build your model. Okay. So that's sort of the basic way to do it. But I mean, we won't be able to see such details in this session. Okay. But at least I hope you understand what is the general structure or the basic structure of building any machine learning algorithm. Okay. You take the data. Okay. You split it into train and test set. You build your model on the training set and then go back and check how good your model is on the test set. Okay. And so let me just show you some plots here. Okay. So this is a plot. Okay. Let me tell you what I'm doing here. Okay. Let me talk about the plot. I won't show you the details of the code, but I'll just discuss this plot and I'll stop here for today. Okay. It's already 9:18 and kudos to all of you, stuck around with me until 9:18. So yeah, you all must be very enthusiastic about data science and machine learning. So, I mean, you had 3 different classes, right? Recall you have Setosa, Versicolor, and Virginica. Okay. Suppose this is like Setosa, red is Setosa. So let me write it. This is Setosa. This is Versicolor, right? And this is Virginica. The green is suppose Virginica, right? So what are we doing here? In KNN, we do divide the entire space into regions, right? Recall that we also drew a map, a plot between height and weight yesterday, right? Height and weight. We had males here, okay? And I think we were using red for females, and we had females here, right? And based on these, we were doing KNN, right? K nearest neighbor. Okay. So what it does is it divides the entire space into 2 regions. Okay. If you take, say, any point from here, right, it would be labeled as red because it's nearer to the red points, right? So you'll have a boundary. Okay. You'll have a boundary. Any point which falls here would be classified as female. Any point which falls here would be classified as male. Okay. Similarly, here also you have 3 regions. Any point which falls here, any query point which falls here, for that the nearest neighbor would tell it to predict as a Setosa, red. Okay. Any point which falls in this region, okay, that would be predicted as Versicolor, and any point which falls here would be predicted as Virginica. Again, the important point here is that we have moved beyond our training examples. We have generalized beyond the training points, right? We can also classify points which fall anywhere in the in this entire space, okay, in this entire graph. That's what machine learning does. Okay. So yeah, so that's all I wanted to discuss today. I mean, it's already 9:20. If you want to leave, you can start leaving. Okay, I'm done with the technical part of the class. But if you have any questions, if you want to discuss something, again, as usual, you can hang around. I can stay for 5-10 minutes more and we can have a discussion. Okay. Again, if you want to unmute yourself and ask questions, you feel free to do so. Okay. Or if you're comfortable asking your questions on chat, you can do the same. I think somebody asked me about how can they access the recorded videos, right? So you can go to the Innomatics Research Labs YouTube page and you'll see, go to playlist and you'll see the first playlist. Okay, the most recent playlist that you have. I think it's called Foundational Course on Data Science. Okay, 2022. Okay, you'll have, I think the first 2 lectures have been uploaded and today's lecture would also be uploaded by tomorrow. So you can watch the recordings again. Okay, if you want to watch the recordings, you can go to our YouTube channel, Innomatics Research Labs, and watch the videos from there. Vikram is asking, what about the blue points lying in Virginica? Blue points lying in Virginica. These are good points. Okay, why do we have these blue points in Virginica? These are in very interesting points. Okay, but we won't be able to cover these things. Okay, I mean, not just blue points in Virginica. There are some green points in versicolor also, right? So there's some green points in versicolor also. It's a good catch. Okay, it's an important point. Okay, but I mean, we won't be able to discuss all of these things. Okay, I mean, it depends on how, I mean, if I change the value of k, okay, I think I have another value of k. So it depends on how you choose your k. Okay, if you change, okay, it's not defined. So I won't be able to run it now because I have to run everything again. So I mean, it depends on how you choose your number of neighbors. Okay, so how many number of neighbors do you look at? Okay, so here this blue doesn't play a role because overwhelmingly everybody is green. If you pick any point in this region, right, because say you're looking at 3 nearest neighbors, the blue can never do anything. Okay, it's always outweighted by the other points. Okay, that's sort of the reason. Okay, and that's a short answer to your question, but I mean, there are a lot of details to these things. Okay, Karthik Singh, can you please explain the Cetosa and Virginica again? Sure. Yeah, so Cetosa and Virginica. So Cetosa, I mean, which part? I mean, what is Cetosa and Virginica? Or I mean, this graph. Can you be a bit more specific, Karthik? Cetosa is like one class. Okay, this is versicolor. Okay, this region is for versicolor. Okay, and this region is for Virginica. Okay. So you have 3 different classes. Okay, you have 3 different classes onto which you are making predictions. Okay, so any point which falls here, that would be classified as Cetosa. Why? Because the 3 nearest neighbors would always be Cetosa. Okay, the majority would always say Cetosa. If a point falls here, okay, it would be predicted as versicolor. Why? Because the 3 nearest neighbor are versicolor. Okay, if a point falls here, then it would be predicted as Virginica because the 3 nearest neighbors suggested Virginica. Okay, that's how these 3 regions are produced. Okay, I mean, the dots are the training points. Okay, but these regions are the generalization beyond the training data. Okay, now I can predict any point that you give me. Okay, so thank you, Shan. So yeah, see you all again tomorrow at 8. Okay, so Chandra is asking how much ratio we have to split training test. Again, these are very interesting questions, but we won't be able to go into these details. Yeah, so here in this case, we are dividing it into 0.25. So it's like 75-25% ratio. So 75% goes to the training set, 25% goes to the test set. But there are many more complicated things that you can do. You can do something called cross validation. If you do not have a huge data set, then you iteratively use your training set again as your test set, and so on and so forth. Okay, you can do very complicated things with these things. Okay, but again, I mean, it's not possible to discuss all of these things in an introductory lecture. Okay, I can point you to references where you can learn about such stuff. Okay. Okay. Any other questions? Okay, so I guess there are no more questions. It's already 9:25, so let's stop here. We'll again rejoin tomorrow at 8. Tomorrow we'll try to learn linear regression, which is like a different kind of an algorithm. Again, we'll learn linear regression and we'll simultaneously see the code, not implement it. Just see the code and try to appreciate how these things are done. Okay, and we'll stop at that. Okay, and on Friday session we'll do deep learning. Okay, so Friday's session would be on deep learning. Okay, so see you all tomorrow at 8. Okay, bye bye. And if you have any questions, please reach out to the team. Okay.